All right, let's talk about variables in C. I know, you think you know them, but trust me, there's a whole secret world hiding behind that simple int x, a hidden blueprint that controls their every move, and today, we're gonna check it out.
Yeah, you know the drill. Int x equals trend. Easy, right? But what's really happening behind the scenes? There's a whole set of rules at play that most people just gloss over. Like, where does that variable even live in your program's memory? Can just any old part of your code come along and see it or mess with it?
And what about its lifespan? Is it gone in a flash? Or does it hang around for the whole party, the entire time your program is running?
Look, getting a handle on this stuff is what separates someone who just writes code from a true architect, someone who builds solid, bug-free programs. So today, let's pull back the curtain and explore that very blueprint.
So, first up, why all the rules? Well, think about it. Without boundaries, it would be pure chaos. Imagine if every single variable in your program was just out there for any part of your code to grab and change. It would be an absolute nightmare to debug. We need territories.
And this analogy just nails it. Some things are private, right? Like your diary. That's a local variable. But other stuff is for everyone to see, like a notice board in the town square. That's your global variable. These scopes, they keep things organized and stop you from accidentally breaking your own code.
Okay, so let's really dig into this idea of the program's layout. The two big ones you gotta know are local scope and global scope. And believe me, understanding the difference is absolutely critical.
Here's another way to think about it, like you're in an office. A local variable, that's the water bottle on your desk. It's yours, it's right there for you. A global variable is more like the big water cooler down the hall. Anyone on the team can use it, and it's there as long as the office is open. All right, let's get a little more technical. A local variable, it's born inside a function, and it dies the second that function is done. It lives in this temporary, fast-moving place called the stack. And get this, it even starts with a totally random garbage value. A global variable, on the other hand, lives outside all the functions. It's there for the entire program's life in a more permanent spot called the data segment, and it's always initialized to 0 for you.
Okay, pop quiz time. Let's say we have a global variable, we'll call it x, and it's equal to 5. But then, inside a function, you declare another variable, also named x, and set it to 10. So when you're inside that function and you try to use x, what value do you get? Is it the global 5 or the local 10? What do you think?
If you said 10, you are correct. The local variable wins every single time. This is a really important concept called shadowing. Basically, the compiler is lazy. It always looks for the nearest definition first. It checks the local room before it ever bothers to look out in the global hallway. So that local x completely hides or shadows the global x for a little while.
Okay, that's cool, but what if the default rules aren't what you need? What if you want a local variable that actually remembers its value between calls? Well, C gives us these special keywords called storage classes. Think of them like special instructions you give the compiler to change a variable's default behavior.
So, here are the big four. You've got auto, which is just the normal default local variable we've been talking about. Extern is for reaching out to global variables and other files. Register is a hint to the compiler to try and use a super fast CPU register, but the really fascinating one is static. It's got local scope, so only its function can see it, but it lives for the entire program. How does that work?
This permanent marker analogy is just perfect. A normal local variable is like writing on a whiteboard. You go into the room, you write on it. You leave, it gets erased. Gone. But a static local variable, that's like using a Sharpie. You leave the room, you come back later, and yep, it's still there, exactly how you left it. Let's see this in action, because it's really cool. Check out this count calls function. See that static int count equals 0? Here's the magic. That initialization to 0 only happens once, the very first time the function runs. So first call, count becomes 1, function ends. But count doesn't die. The next time you call the function, it picks up right where it left off at 1, adds to it and becomes 2, then 3, and so on. It remembers. This is so powerful. So we've got variables that are temporary and variables that stick around. But what about the things that should never change? Like the value of pi or the maximum number of players in a game. For that, we need constants. They're the rock-solid foundation of a well-built program. Yeah, a regular variable is like writing in pencil. You can change it, erase it, whatever. But a constant,
made with the const keyword, that's engraved in stone. It is a read-only. If you even try to change it in your code, the compiler will slap your hand and say, nope, not going to happen. It's a fantastic safety feature.
Now this is a classic C gotcha. Const versus hash define. They might look like they do the same thing, but they are worlds apart. A const variable is a real variable. The compiler knows about it, it has a type, it's stored in memory. But hash define, that's just a dumb, blind text replacement tool. The preprocessor just does a find and replace before the real compiler even sees the code. It's way less safe because you lose all that nice type checking.
Okay, we've got our program's internal blueprint figured out. We have our private local rooms and our public global hallways. But how does our program actually talk to the outside world? We need some doors and windows. In C, our main doors and windows are functions like printf and scanf.
Let's start with printf, our window out to the world. And printf is about more than just spitting out data. It's about presentation. Think about it like laying out a newspaper. You don't just dump text on the page, right? You use columns, you control alignment, you make sure prices look like $10.50. You can do all of that with printf.
And we do that with these little format specifiers. For example, %5d tells the computer to save 5 spaces for an integer, which is awesome for lining up columns of numbers. Or %2f will take a float and neatly round it to 2 decimal places. It's these little details that make a program feel polished.
All right, now for the door in, scanf. This is how we get input from the user. And listen up, because this function is way more dangerous than printf. The #1 mistake C beginners make is forgetting that little ampersand, the and symbol. And this delivery guy analogy explains why it's so vital. Scanf is a delivery guy. If you just tell him, deliver this package to age, he's going to be lost. What's age? But if you give him the house address of age, which is what and age means, he knows exactly where to drop off the package.
And I'm not kidding about the danger. If you forget that ampersand, your program will almost certainly crash with something like a segmentation fault. That and is not optional. It is the absolute key to how scanf works. You're not giving it the variable. You're giving it the address of the variable. So there you have it. We've just walked through the entire hidden blueprint of a C program. From the private rooms of local variables to the public hallways for global ones. From the permanent marker of static to the stone tablets of const. The secret life of variables, well, it's not so secret anymore, is it? So the real question is, now that you know the blueprint, what kind of programmer are you going to be? An architect who builds with purpose, or one who just lets variables run wild and create chaos? The choice is yours.